Today what we're going to do, guys, is the division algorithm. We're going to continue on this, but we're going to work on converting the decimal division into whole numbers and division using fractions. So the fractions is going to give you guys kind of a in-between step to understand why we're doing what we're doing to divide by decimals. Okay? Here's what, again, I just so love Engage New York. We're converting decimal division, right? And the first problem they give us is fractions, yay! But it will help us set up what we're going to do. So in this case, I'm not minding it as much. Now, one thing we haven't really talked about is tape diagrams on our division. So I'm going to just show you guys a quick tape diagram on the division piece. One key in using tape diagrams in division is I need a common denominator, because that's what I'm going to make my tape diagram on. In this case, we actually have one in tens. So for my tape, I'm going to actually just draw a section of tens, because I'm looking at tenths that I'm dividing it into. On my top, what I'm going to do is I'm going to do the 1/2. So 5 of the 10 is 1/2, correct? And if I'm dividing this into 1/10, so that's going to be each of these little sections. So I end up with 1, 2, 3, 4, 5. So how many 1/10 are there in 1/2? 5 of them. Can everybody see that? So I'll give you a minute to write that model down so you have an example of what these tape diagrams look like. Now that you've got the model, let's relate this to what we talked about as to how we actually divide fractions, which is our multiplying by the inverse, the reciprocal, right? So if I write it down, it's going to be 1/2 divided by 1/10. How do we actually divide fractions? That's our key. So I do the 1/2, change it to multiplication, flip, 10 over 1. I multiply by the inverse of the reciprocal. Once I'm in multiplication, now I can look for my reductions. Divide both those by 2 becomes 1 and a 5. 1 times 5 is 5. 1 times 1 is 1. 5 over 1 simplifies to just 5. So we can see mathematically what our model expected us to be able to see. Go ahead and turn your page. And here's kind of the crux of what we're going to be doing today. So now that we understand that whole fraction piece, well, let's look at this from a decimal standpoint. So we use a tape diagram again to support our answer. So in this case, we're going to have 1/2, or 5/10 divided by 1/10. So if I do my model, I'm going to do 5/10. I'm going to divide my whole 1 into 10. So if I have 5 of those tenths, and I'm dividing it into 1/10 sections, how many of them do I end up with? 5. So again, our model is showing if I do 5/10 divided by 1/10, I should get 5. So if we're going to write this now as a fraction, which comes in the numerator, the first number or the second number? First. My first one is my numerator. The second number is my denominator. Now we're going to talk about something we haven't talked about a whole lot so far, and that is the power of 10. When I multiply and divide by tens, literally all I'm doing is moving my decimal. Somebody good with that? We need to go deep into it? Okay? When we multiply by 10, for every power of 10, I move it once to the right. So I multiply by 10, I'd move it 1 time. If I multiply by 1,000, I would move it 3 times. If I multiply by 10,000, I'd move it 4 times. Basically, for every 0 in the power of 10, I'm moving my decimal once. Same thing actually goes on dividing, but then I'm going to move it left. So if I divided by 100, I would move it left 2 times. Okay? But today we're going to focus on moving it to the right, because what I really need is I need my divisor, or my denominator, to be a whole number. So how would I go from 1/10 to a whole number? I would multiply by 10. Now, did anybody listen to what I said as I said it? What was the number I talked about? 1/10. And I said I have to multiply by 10. Guess what? If you will say your decimals properly, guys, you're actually giving yourself what you need to multiply by. You're multiplying by the place value. So in this case, 1/10 times 10 means I move it once. 5/10 times 10, I move it once. So that actually becomes 5 divided by 1. So what does that equal? 5. So what we just did, we did this step is this one right here. So we just did it all in one step. So what we've done so far, is this making sense? Do you see logically how these flow? Okay, I've had a couple shaking their heads. So let's, if we go back to the first page and we look at these fractions, what fractions did we use? 1/2 and 1/10. On our second page, what decimals did I use? 5/10 and 1/10. So if I turn that into a fraction, 5/10, remember, say it, write it, simplify it. So 5/10 I would divide by 5. That is actually 1/2. 1/10, say it, write it, 1/10, simplify it. Can't simplify that. So really, when I did this decimal, we just did the fractions we did on the first page. It's 1/2 divided by 1/10. Does that help you see that connection? All we did is look at the numbers in a different format. Instead of fractions, we're now looking at them as decimals. I will tell you right now, guys, the whole key to today's lesson, and I want you to go ahead and write this in. Write down, where can we do this? Let's put it right here above exercises. Focus on making the denominator a whole number. That is our whole focus for today. If we can make the denominator a whole number, then we can do the math. So on these next exercises, these are really simple. All we're doing is practicing changing the decimals to fractions to make them whole numbers. Okay? So our first example, they gave us 18 and 6/10 divided by 2 and 3/10. They said, okay, let's write that as a fraction. 18 and 6/10 is my numerator. 2 and 3/10 is my denominator. When I say it, 2 and 3/10, I know I need to multiply by 10. So as I multiply both those out, I get 186 over 23. So rewritten as a whole number, that is 186 divided by 23. We good on that one? Since I did it for us, should be. So our next one, we're going to do the exact same thing. So I'm going to rewrite my problem as a fraction. So 14 and 4/100ths divided by 4 and 68/100ths. So, unfortunately I said it. Let's see who was listening. Who can say the denominator for me mathematically correctly? Evan?
6800.
Hundredths, meaning I'm going to multiply by 100. Whatever I do to my denominator, I must do to my numerator. So hundreds just means I'm moving my decimal 2 times in both cases. So now I can rewrite this one as 1,484 divided by 468. We don't actually have to do the math on that one. We can just we're just writing them for right now. Everybody good? Okay, so go to the next page. I know it's on the same page for you guys. We're going to do the same thing on this one. So I'm going to rewrite this as a fraction. So 162 thousandths divided by 36 thousandths. So what place value did we say for the denominator? 1,000. So I'm going to multiply by 1,000. Anything I do to the bottom, I must do to the top to keep it even. So I'm moving 1, 2, 3, moving 1, 2, 3. That becomes 162 divided by 36. Does everybody understand the process we're going through? Okay? Now, my question to you is, why are we doing this big focus on making my denominator a whole number? I'll give you a hint, do we divide by fractions? No, instead we had to do what? No. When we divided fractions, what did we do? How did we get our answers? Keep, change, flip. I had to multiply by the reciprocal, right? We couldn't actually divide by fractions. Mathematically, it just doesn't make sense. We're looking at the same thing. It doesn't make sense to divide by parts of a number. I can't really tell how many parts of a number are in a number that it just mathematically it doesn't work. So instead of doing that, we use the powers of 10 to make them both whole numbers, or at least the denominator. Honestly, the numerator doesn't matter. I can still have a decimal in the numerator and I'm fine. So let's take a quick look. I'm going to add one in here for you. What if I did something like this, where I had a problem, we'll say 1,564 divided by 8 7/400ths. Again, where do I focus? The denominator. So what am I going to need to multiply by? Somebody understand that? So I'm going to multiply them both by 100. So I'm moving my decimal twice. 1, 2. Uh-oh. I don't have a decimal on the top one. Where's my decimal if I don't see it? At the end, right? So it's actually right here. So if I move it right, I'm only going 1, 2. What happens to empty buckets? Empty buckets get zeros. So this one would be rewritten as, I'm going to have to do it over here, otherwise you won't see it, 1,564,000. So 156,400 divided by 874. Is everybody okay with that? So if you don't see the decimal, you still know where it is to be able to move it, correct? Layla, you good? You got that written down? Make sure you write it, please. So I'm going to do one of these together, and then I'm going to let you guys go and get some good practice on these. Our first one, we're going to evaluate the expression. What does that word evaluate mean? We haven't really talked about that much. Solve. Evaluate means solve. It means I want to know what the answer is. Okay? So first, they want us to convert the decimal division to fractional division to find a whole number divisor. Then we're going to evaluate. So we're going to write it as a fraction, 25 2/10 divided by 72 hundredths. So what am I going to multiply by? 100 or 100. 100, because it's 100ths in the denominator. So multiply both by 100. That moves twice. Here's my decimal. Move twice again. Empty buckets get a 0. So what I'm really doing is 2,520 divided by 72. Here's that division algorithm again. That's your table. Guys, these tables should be super, super easy for you. I have some students, I was just arguing with one last period. She literally had like 6 times did the multiplication. I'm like, for the time it took you to do that, you could have done this table twice. 2, 3, 4, 5, 6, 7, 8, and one more is 9. Okay? Now, people seem really amazed at how quickly this goes, but this is literally just adding, guys. I am not doing any mental math, believe it or not, because the numbers are literally right in front of me, aren't they? Do you notice how I'm going from right to left? Do you know why that is? Because that's how we add, right? So what did I just do? I said, well, 2 plus 2 is 4. 7 and 7 is 14. I now have the numbers right in front of me, don't I? So I just add. 2 and 4 is 6. 7 and 4 is 11. I know mentally I'm carrying a 1, plus that 1 is a 2. I'm now working off of this row, putting in the line since you guys can't see me point. That's 2 and 6 is 8, 7 and 1 is 8, nothing and 2 is 2. Now I switch my focus from that row to this row. But I've already got what I'm adding written right here. So I don't have to rewrite it. It's just 2 plus 8 is 10, 7 and 8 is 15, plus my 1 is 16, nothing and 2 plus the 1 that I just carried is a 3. Now I switch my focus to this line, because that's where I'm at. 2 and 0 is 2, 7 and 6 is 13, nothing and 3 is 4, with the one I carried. And just keep doing that each time. But your numbers are literally written right in front of you. So adding these should be easy. Basically, as long as you know your addition facts up to 9 plus 9, building this entire table should take you 30 to 45 seconds at max. And half that time is going to be drawing the outline. Everybody good? Once I've got my algorithm, doing the actual math should be extremely easy. 2,520 divided by 72. Will 72 go into 2? Nope. Into 25? Nope. 252, I look at my table. That's the closest I can get without going over. So subtract 216. Gets me 6, 3, bring down the 0, 360. There's my 5. And I'm done. So while initially 2,520 divided by 72 may look like a daunting thing to do, it's not. That whole problem literally should take you maybe 2 minutes, 3 minutes if you're a little slower on the table. Make sense, guys? Does everybody understand what we're doing? Good, because I'm going to give you guys a chance to practice now. So if you'll turn the page 64 and 65, numbers 4 through 7. We're going to give you guys roughly 20 minutes to finish up those 4 problems. We'll come around and help you if you need it. Okay, we're going to do them fast. 2,000 over 3 and 2 tenths. I just set it as 2 tenths, so I'm going to multiply by 10. My decimal's not there, it means it's at the end. So that's going to be 20,000 divided by 32. Build my table. I think most of you, at least on my side, are getting much more used to building these tables and realize they're really not hard to do, especially if you're able to identify a pattern. They go super quick. So 64, 96, 128, 160, 29, 192, 224, 6, 5, 2, 8, 8, 2, okay? Once I have those, doing the actual math is extremely easy. I've got a cheat sheet. 200, it's going to go 6 times. Subtract 192, gives me 8. 80, it's going to go twice. Subtract 64, gives me 16. 160, bang, it's right there. So my answer, 625. Pretty good so far? Okay. Next one. 3,581 and 9 tenths. Divided by 4 and 9 tenths. Again, we focus on the denominator. We said tenths. So I'm going to multiply by 10, meaning I just moved my decimal once. So I rewrite it, it's 35,819 divided by 49. Building my table. Super easy. Four, 5, 6, 7, 8, 9, 49, 98, 147, 196, 245, 294, 343, 392, 441. So again, if you find patterns, that's really easy, right? I was going 49, 49, 49, just going down by 1 and 1. Super simple. So 35,819 divided by 49. Not going to go in the 3 or the 5. So 358, we're looking at 7 times. Subtract 343, gives me a 5, 1, bring down a 1. 151 is going to go 3 times. Subtract 147, gives me 4, bring down a 9. 49 is going once. So my answer was 731. Everybody good? My next one. Here we start 893 and 76 hundredths divided by 21 hundredths. Hundredths in both times, so I'm going to go by 100. Means I'm moving it twice. So that's going to be 89,376 divided by 21. My table. Honestly, all of them are really easy. This one would be super easy. It's just 21, 42, 63, 84, 105, 126, 147, 168, and 189. Okay? So 89, 376, 21. It's not going to go to the 8, but 89 is going to go 4 times. Subtract 84 gives me a 5. 53, it's going to go twice. Subtract 42 gives me 11. So bring down to 7. 117, it's going to go 5 times. Subtract 105 gives me 12. 126, it's going to go 6 times. So my answer was 4,256. Okay. Am I going too fast? Hopefully we're just checking our work, so it's not a big deal. Our last one, 6 and 194 thousandths divided by 326 thousandths. Again, in my denominator, I said thousandths. So I'm multiplying by 1,000. Gives me 6,194 divided by 326. This table shouldn't have been that bad. 1, 2, 3, 4, 5, 6, 7, 8, 9. Because all I'm doing, 3, 2, 6. 6 and 6 is 12. 2 and 2 is 4, plus the 1 is 5. Gives me a 6, 8, 7, 9, 14, 10, 12, 13, 10, 3, 6, 6, 5, 9, 12, 8, 12, 8, 10, 5, 6, 14, 3, 9, 2. Uh-oh. You're not hearing me at home very well. Let me try that again. Anyway, so hopefully that table wasn't too bad, right? So 6,194 divided by 326. It's going to 619 only once. So I subtract 326. Gives me 3, 9, 2, 29, 34, 9. I needed the beginning and the end of my table. So my answer was 19. Make sense? How are you feeling on those, guys? Let's do a thumb meter. Liam? Andrew? Not seeing your thumb meter. Okay, looks pretty good, guys. Okay, let's turn the page. Before we do this one, we're actually going to go to lunch, I think. Okay, example 3, we're actually going to walk through it. We're going to basically put everything we've done together over the last couple weeks. So we have a plane that's traveling at 3,625 and 26 hundredths miles in 6 and 9/10 hours. What is the plane's unit rate? So this is going all the way back to the start of Module 1. Okay? We're going to start representing the situation with a fraction. So as a fraction, that's going to be 3,625 and 26 hundredths over 6 and 9/10. Now we're going to do the same thing using the same units. So 6,000 or 3,625 and try this again. 3,625 and 26 hundredths miles over 6 and 9/10 hours. So that, as a reminder, is a rate, correct? We've now included our units. So we've gone from a fraction to a rate. Now we're going to do an estimation. Estimate the quotient. So if we start an estimation, where do I start? Top or bottom? Bottom. Because it's the number I'm going to divide by, I do first to make sure that I've got an easy one to go into the top one, right? So 6 and 9/10, I'm going to estimate and go to 7. So now I need a number that's going to be close to 3,600 that's going to work well with 7. 35, right? So 3,500. So we have our reduction, goes 1 and 5, 5 with 2 zeros. So it's going to be somewhere around 500. Again, guys, the estimate should be very quick. You're literally making the numbers easy to do. Okay? Now, express the divisor as a whole number. So we're going to go back to our initial ratio, 3,625 and 26 hundredths, divided by 6 and 9/10. Again, since it's been lunch, we'd focus on our divisor, right? So we said 6 and 9/10. So what am I going to multiply by? 10. So if I do them both by 10, I'm going to end up with 36,252 and 6/10. And I'm dividing by 69. Does it matter that I still have a decimal in my numerator? No. Doesn't matter. Because when I'm dividing, he's going to be inside the house, right? The top guy, he's the winner, and goes in the house. In the house, we use decimals all the time. It's the outside of the house we can't have a decimal. At this point, we're ready to build our table. One through 9. And I'm making the number of 69. So again, I think a lot of you have gotten to the point where you're able to see the patterns. Patterns is the number I was looking for. So this is basically 70. So I'm going to be going up by 7s. On this side, it's going to be 9 and 9 is 18. 6 and 6 is 12. Plus 1 is 13. So I'm going to be going down by 1, up by 7. Down by 1, up by 7. And that's going to go all the way through here. 34, down by 1, up by 7. 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 Once you have your table made, now we just do the math. So 36,252 and 6/10 being divided by 69. We'll go to 3. No, we'll go to 36. Nope, 362. Now I'm looking at my table. 362. Oh, it doesn't look like it, but that's actually a 3. So 345. So that's going to be 5 times. Subtracting 345 gives us a 7 and a 1. The 5 comes down. 175 is going to go twice. So I'm subtracting 138. Gives me a 6, 7, 3. Bring down the 2. 372 is going to go. Do something wrong? Why are you saying wait?
It's 72, I thought.
No, because I had to borrow from the 7.
Oh, yeah, sorry.
Okay.
6 minus 2 is 4.
6 minus 3 is 3.
I probably did something wrong.
Okay. So I'm at 372. Don't forget, guys, your decimal. Bring down the 6. No. 3. Oh, I forgot another way to go. That was that. I haven't done that yet because you messed me up. Subtract 345. That's going to give us 7 to 276. Don't forget to bring your decimal straight up in your problem, and it comes out at 4. So what was our answer? 525 miles and 4/10 miles per hour. Was that close to our estimate? Very close, actually. So we said it was going to be around 500, 525, just over it. So all those things go together? What's wrong, Jayla? Any questions on any pieces of this? Okay, go ahead and turn the page. Now, on this one, convert decimal division expressions to fractional and to create whole number divisors, and we're going to go ahead and make sure divide. So we want you to solve the first 6. That's why we limited it to 6. The good news is you get to cross all the rest of them off.
And if you need to show your work, which you obviously need to show your work with this math, the back of the page is empty.
So if you turn the page over, you can see you got that whole next page to show your work. Okay? Any questions on what your homework assignment is? So again, make sure you're doing the actual division on these problems, guys. But most of them actually work down to 1-digit divisors. It should be pretty simple for you to do. So, that's it for today.